Chapter 10, Section 3 is about adding, subtracting, and multiplying radicals. So we're going to talk about how do we handle the problems where you start seeing plus and minus signs in between your radicals, and how can we get them to be similar so that we can try to combine them and simplify these expressions as much as possible. When you're adding and subtracting radicals, they have to be identical in order for you to be able to combine them. So it's very similar to what you've had to do in the past when you were trying to combine like terms. For example, when you were dealing with algebraic expressions in the past that just had letters or numbers in it, you could only combine things that looked alike. So you could only combine your x's or your y's or your z's or your numbers, or if they both had x squareds, or if they both said x squared y to the third. Like, you could only combine them if the letters that were attached to them looked the exact same. The rules still apply when you're dealing with radicals. So for example, I have 2 and a square root of 3 plus 5 plus 7 square root of 3 minus 2. When I look at these, I see some with radicals and some that are just plain numbers. Like 5 and the negative 2 are just plain numbers. So I could combine those. The 2 square root of 3 and the 7 square root of 3, those are like each other because they both have that same radical 3. Think of that radical 3 as like an x. It'd be the same thing as like if I wanted to take 2x plus 7x. So when you're adding or subtracting like this, you want to find your like terms first and then combine them. So when you're combining things with radicals, like the 2 square root of 3, the 7 square root of 3, you only add or subtract the whole numbers in the front. So 2 plus 9, or 2 plus 7 would be the 9, and the square root of 3 is going to just stay. For the numbers, 5 and a negative 2, 5 plus negative 2 or 5 minus 2 is how they got 3 down here. And so this would be our simplified answer based on what we had given to us. Now, if it appears in a problem like nothing looks the same, like this one, everything looks different, you're going to want to make sure that your radicals are reduced first before you jump to conclusions and think that you can't do anything with this. So what I mean is you're going to have to look at those square roots, try to break them apart, see if there's any reducing that you can do before you try to combine your like terms here. So for the first one, 3 and then the square root of 45, these are all regular square roots, so I'm looking for groups of 2. So I'm going to break that down to 9 times 5, and 9 would be 3 and 3. And there's your group of 2, those 3's there. So remember when we did this in the past, this would be like 3, and then underneath the square root you'd have 3 squared times 5. Moving on to the 20, this would be like 5 times 4, and 4 would be a group of 2 because you've got 2 2's there. So underneath that square root we would have 2 squared times 5. For 245, I could break that apart to 5 times 49. 49 would be 7 times 7, so there's your group of 2. So it'd be minus the square root, we'd have 7 squared times 5. And 3 is already prime for this last one, so there's not going to be any groups of 2 that I can find. So I'm just going to write plus the square root of 3 there. So now what I'm going to do is see if I break these out, like start taking out my groups of 2, what I'm going to be left with. So when I take out the 3 squared on this first one, because there's already a 3 here, when this 3 comes out, you're going to have to multiply it to the 3 sitting in the front. So this is going to become 9 square root of 5, because you can't do anything with the 5 because it doesn't have a group of 2. 2 squared, the 2 will come out, so plus 2, and then square root of 5. Minus the 7 will come out of this square root, so it's 7 square root of 5, and then plus the square root of 3. So now if you look at your problems, these 3 are all like each other because they all have that square root of 5 attached. So I'm going to do 9 plus 2, which would be 11, minus the 7, which would leave us with 4, and then we have square root of 5 attached to it, and then I have this plus square root of 3 just added on to the end because this is different than those other 3, so I'm not able to combine it. So I want you guys to practice this here. Try to reduce these square roots first before you try to combine your like terms. So go ahead and pause the video, try this out, and then continue to watch. So again, this one has all square roots, so I'm looking for groups of 2 here. So 27 would be 9 times 3, and 9 would be 3 and 3. So we've got that 3 sitting out front, and then underneath here, I am going to still do it like this, like 3 squared times 3. I know I could write it as 3 to the 3rd power, but remember I'm looking for groups of 2, so I want you to be able to see that group of 2 that you're going to end up taking out of the square root sign. For the next one, for 48, we have 3 times 16, and 16 would be 4 and 4, so there's your group of 2. So this one was a 2 in the front, and then we had 4 squared times 3. For 12, that would be 3 times 4. 4 would be 2 and 2. So minus 2 squared times 3. And the last one here, the 72, we could break that to 2 times 36, and 36 would be 6 times 6. So this would be plus 6 squared times 2. So now I'm going to start taking out my groups of 2, and remember if there's a number already sitting in front of the square root, like these first 2, you're going to have to multiply them. So this one, 3 times the 3 out front becomes 9 square root of 3. This 4 comes out, so you'd have plus 8 square root of 3, minus 2 square root of 3, plus 6 square root of 2. The only like terms I see are these first 3. This one has a square root of 2, so it's a little bit different. So 9 plus 8 minus 2 would leave you with 15 square root of 3, and then plus 6 square root of 2. Now we're going to move on to multiplying radicals. Multiplying radicals I think is a little bit easier because you don't have to have them be like terms in order for you to combine them. The steps that you want to follow when you're multiplying radicals are you multiply the numbers that are outside of the radical, so the whole numbers that are maybe sitting out front. Then you multiply the numbers that are underneath the radical sign, and then you reduce if you can. So for example, if I have 2 square root of 3 times 4 square root of 6, I would start by multiplying my numbers, so 2 times 4, which would be 8. And then next to that, you're going to do your square roots. You're going to take the square root of 3 times the square root of 6, which all that means you're going to do is multiply those numbers underneath the square root. So 3 times 6 is 18. So we have 8 square root of 18. But now I'm going to see if I can find a group of 2 within 18. So 18 would be 9 times 2, and 9 would be 3 and 3. So there's your group of 2. So when you pull this 3 out, you'll have to multiply it to that 8 that was already sitting out front. So 8 times that 3 we're taking out is going to be 24. Don't forget about this 2. That's got to stay underneath the square root sign. So you guys try this one. Multiply those and then reduce them. So you should have done 4 times 2, which is 8, and underneath the square root 2 times 6, which is 12. For 12, you can break that apart to 4 and 3, and 4 would be 2 and 2 for your group of 2 there. So you pull out your group of 2, take it times that 8, which would be 16, and the 3 has to stay underneath the square root sign. Now if we're multiplying something that looks like this, where we have terms that are being multiplied but there's plus or minus signs in between them, we have to use a method that we call FOIL. What FOIL stands for, the F stands for first, the O stands for outside, the I stands for inside, and the L stands for last. And this is just a way that you can think about multiplying these together so that you're getting those terms matched up appropriately. So your first terms would be to take the 2 square root of 3 times the square root of 3. And that would become 2 times the square root of 9, which the square root of 9 is a 3. So 2 times 3 becomes the 6, and that's what they have right there for that first term. Your outside terms would be the 2 square root of 3 and the 6 square root of 5. So they're the terms that are farthest apart from each other. So 2 times 6 is 12, and underneath the square root you have 3 times 5, which is the 15. So that's how they got that outside term, which is the second one they have written down here. Your inside terms would be the terms that are like right next to each other, where these parentheses kind of butt next to each other. So we have 4 square root of 5 and the square root of 3. So 4, there's a 1 here, so 4 times 1 is 4. And then square root of 5 times square root of 3 is that square root of 15. So that's the next term in our sentence. And then last would be the 4 square root of 5 and the 6 square root of 5. So the ones that are at the end of both parentheses. So 4 times 6 is 24. And then again, we've got the square root of 5 times square root of 5, which that 5 will just come out. So 24 times 5 is how they're getting that 120. The last thing that they did here is they combined like terms. So they saw the 6 and the 120 to get us 126. And then the 12 square root of 15, the 4 square root of 15 together would be 16 square root of 15. And then again, you would want to see if there's any reducing you could do. But 15 is not going to have any groups of 2 in it because the only prime numbers that are in there are 3 and 5. So you're not able to do that with this one. So for this last practice problem, go ahead and give that one a try and then keep watching the video to see if you did it right. So for this one, your first terms would be the 9 times 4, which would be 36. Your outside terms would be the 9 and the negative square root of 10. So that would be negative 9 square root of 10. For your inside terms, you would take 2 square root of 5 times the 4, which would become 8 square root of 5. And then last would be the 2 square root of 5 times that negative square root of 10. So it would be negative 2 square root of 50. Now if you try to look for groups of 2 within any of these, 10 would factor to 2 and 5, so there's no group of 10 there. 5 is already prime, so you don't really need to break that one apart. For 50, if you do 2 times 25, 25 would be 5 and 5, so there's a group of 2 that you could pull out of that square root sign. So I'm going to bring everything, these first 3 terms down. And for this last one then, that group of 5, so if 5 comes out, you take it times that negative 2 in the front, which would be negative 10. But then don't forget about this other 2 that we had. So that would say underneath the square root. Looking at this, there's no like terms because they're all different enough from each other, so you would not be able to reduce it beyond this point.